Good morning, good afternoon, and good evening, everyone, depending where you are joining. My name is Alessandra, and I'm going to be your moderator today. Our webinar today is going to be continuously securing the software supply chain, and I'm super excited to show you everything we have new here in JFrog. And just a few housekeeping items before we get kick off. This webinar has been recorded, so don't worry if you miss some part. In 24 hours, you will have the recording. We are live, so feel free to answer question in our Q&A box. And for every other question, feel free to schedule a meeting with us, to reach out to us at the address webinars@jfrog.com. And now, I'm super happy to introduce you our speaker, Bill Manning, our solution engineer manager at JFrog. And I don't steal you more time. And Bill, thank you again for your help. And the stage is yours.
Should we wait for some more people to join, or should we just kick it off right now? I think we should just kick it off. What do you think?
If you want to wait 1 minute, we can wait.
No, you know what we'll do? Actually, I think this will be a good time to kick it off. Everybody else can kind of jump in as we go, but let's give it a go. So, hi, everybody. How you doing? And welcome to Continuously Securing Your Software Supply Chain, right? And just so you're aware, I'm William Manning. Call me Bill if you want. My Twitter is, of course, William Manning. I am actually one of the solution architects and also solution engineering managers here in the Americas. Been with JFrog for almost 6 years now. And today we're going to be talking about the importance, right, of software supply chain. This is a very hot topic. We've talked about it many, many times, you know, in many different contexts. But, you know, basically what it comes down to is this, right? Software supply chain is one of the most critical things that companies are looking at these days, right? It's affected so many companies, and it feels like this, right? We're trying to do our jobs as, you know, developers or DevOps engineers, security engineers, whatever you're doing in an organization, you know, managing and maintaining that ability for you to, you know, take control of the software that you build. You know, you need to do things, right? We see, you know, all the time in a typical development cycle. You know, if you're a developer, you know, you get handed a task, you choose a language to, you know, do it, you know, best. It's usually done by like an organization. Maybe NPM is what you've chosen for, say, like maybe a web service or things like that. You start to, you know, formulate how you're going to build your code. You go through, you create your, you know, your project, and one of the key components there is, of course, package.json, where you actually usually, you know, exemplify your dependencies that you use. You do an NPM install. It goes out to a third-party source, and it brings down the implicit ones that you said directly and all the indirect transitive dependencies that come along with it. I always jokingly call NPM the house party. You invite 3 things in your package.json and 500 show up, right? These are just the way things are. And the thing is that your software, the things that you build, 85 to 90% of the software you build is someone else's software, right? Are those core components you bring in, all those third-party direct dependencies, both direct or implicit, and also to all the associative transitive dependencies that come along with it too, right? Because those dependencies have dependencies, and it can get very daunting and very overwhelming over time. And software supply chain is, you know, how do you address it? And how do you do it in a way, you know, that means more and actually costs less, right? Because the thing is any sort of software supply chain attack costs money, which we'll talk about in a bit. But the thing is that having the tool sets to have it so that your organization can do what they do and do it, you know, succinctly and do it in a way that's safe and secure is really one of the key features here. Just so you know, I mean, I come from a development background. I started my career many moons ago, you know, doing software development. Started off with like waterfall, you know, where you do like quarterly releases, and then over time time, DevOps took over, in 2006 when the CTO of AWS was like, if you build it, you run it, right? And then, people started doing smaller microservices, smaller releases, get it out there faster, all these things. But you got to remember, there's still coders involved like myself that started in this field and do these things. And, I always equate coders to artisans, right? They're artists. They really are. And the tools and the palettes that they use to create the things that they create are those third-party transit dependencies, right? If you're going to go with the Vaughn Ross thing, they always pull out that titanium white and stuff. But the thing is that, you want them to be able to innovate. You want them to be able to go ahead and do the amazing work that they do, but you also want to remove restrictions, but also have restrictions, right? You want them to operate as efficiently as possible, but also ensure that they're not doing something potentially malicious. I mean, the thing is that of the code bases, 99% of all code bases are those open source components, and 75% of those contain at least one major or open source vulnerability. Think about that. You're basically inviting things into your organization. And the thing is that 49% of the code bases analyzed have at least one high-risk vulnerability. And of that, 90% of the applications out there had components that were old or outdated or completely abandoned. Think about this. You're building the latest software with tool sets that have been old and outdated, or just people built it and then just walked away from it. And we read these headlines all the time as developers and security people and DevOps engineers and managers, whatever. We see these everywhere, and it can be scary. I mean, we are a CV, CNA, just so you know, we're a CVE number authority, as you can see here. We're constantly publishing articles about this because we have almost 8,000 customers, right? Almost 100% of the Fortune 100, top 10 banks, automotive, you name it, we're there. We're actually one of the biggest little companies you've never heard of sometimes, right? Everybody says, oh, I know Artifactory, but they don't know JFrog. But we're a company out there that's actually giving back to the community to help our customers protect their assets. Because let's face it, anytime you actually do anything around security, you're detracting time from innovation, which is costing money. We actually have our campaign that we're talking about right now internally, which is basically innovate more and remediate less. And software supply chain attacks is nothing new. This is not a new thing. This has been around for a long time, but it causes problems. I mean, the one that everybody always talks about, I've talked about this thing for years now, is the idea of, SolarWinds. It was really the one that everybody uses as kind of the unfortunate gold standard of vulnerabilities and risks, right? I mean, in fact, 18,000 global customers, $100 billion remediation. It affected companies and governments and everything. And it was a fourth level transitive dependency. It wasn't even an implicit, it was an indirect transitive dependency that caused this issue. And the thing is that, as developers, right, as build engineers, whatever, I love this quote, every time you do a pip install, a go get, Maven fetch, or anything like that, it's the equivalent of plugging a thumb drive into your production server. This is so true. Think about this. Your company is built on revenue, but that revenue comes from an inherent layer of trust that your customers have with you, that what they're doing isn't going to be potentially malicious or nefarious to them, right? And it's not just losing money and things like that, it's also losing reputation. So how do you safeguard yourself? Because software supply chain attacks themselves are really funny because they're low effort, doesn't take a lot of skill either, just so you know. You don't really have to do much. High-speed attacks spread so quickly because depending on the language type you're using, NPM, Python, we support over 32 package types natively out of the box. There's sources for these, right? Those library sources. And getting into that community is pretty straightforward. Making small modifications and adding in, say, a third-party transit dependency that maybe 4 levels deep, like SolarWinds. They compiled the software, it came in unbeknownst to them because, it just comes in to build the software as part of the build process. It's just another dependency. It allows them to spread these attacks that they do, whether it's typo squatting, binary spoofing. There's a multitude now of things that are out there that are potentially threatening. And the thing is, this abuses the trust relationship, right? Companies are now becoming more trepidatious with utilizing some of these components and are looking at ways to ensure safety and security on those third-party transit dependencies that can do things where they might introduce a backdoor or even malicious code. I mean, SolarWinds was elegant in its nature, right? I mean, the fact that it installed the software and it didn't do anything until 14 days after the piece of SolarWinds software was actually turned on. 14 days later, havoc and mayhem ensued, and the whole world went crazy, right? But these are things, how do you protect yourself? How does your organization do it in a way that is fully protected, but non-intrusive, and also allows the developer to spend, like I said, more time in innovating and providing with a tool set that allows them to both pre-evaluate binaries, consistently evaluate binaries, everything from shift left to ship right, right? So from developer to device, code to cloud, I work with the government a lot, compile to combat, all these kind of things. And just so you're aware, I'm not just talking about minor things here. There was a 650% increase in 2021 on supply chain attacks. In 2022, that increased by 40%. Think about that. That is insane. The sheer volume and the sheer number of ways now that you have to protect yourself. That open source community is the best thing that ever happened to you. And also too, there's a level of precaution that comes with that. Vulnerabilities cost companies on average $4.5 million, right? That's up from 2021 at 4.3. And the thing is that one of the biggest problems is also too the amount of time it takes, because listen, identifying a problem is one thing, being able to resolve it and remediate it is another. But understanding the blast radius, how long have we been affected by this issue? You know, is this an ongoing thing? And to find that out, it takes time and effort. I'm going to show you some ideas here that I talk to customers about, because here's the thing, is that when you look at these binaries, they're not just used in most places in one place. They might be used in multiple places. And that's the reason why we're here today. Why does this webinar say continuous security? So for one of the things you need to recognize is that you're not aware of the way we store the binaries in Artifactory directly correlates to the way we can have continuous security. You hear about continuous integration. You hear about continuous delivery. We talk about continuous security. Because whenever you upload a binary into Artifactory, into one of our repositories, and we'll talk about repositories as how you organize them, but let's talk about the storage aspects of it, right? So anytime you ingest a binary, if you're going to upload it into our product, into Artifactory, or you're going to use it as, proxying through our remote repositories, the third-party transitive dependency you have, we store it into a file store. So Artifactory, our storage layer, is broken down simply this way. You have a binary. And the binary, you want to put this into Artifactory, whether it's, like I said, a third-party transitive dependency that is either implicit, so it's direct or indirect, or a build or a file or anything you upload. We actually store the file as a SHA-256, right? Docker images or whatnot. Like I said, we have over 32 package types that we support. And the actual file itself is stored as that actual checksum. And then in our database, we actually reference the actual physical file that is in there. And we actually give the path to it. So even though it's stored as this obfuscated SHA-256 value, we actually reference in the metadata. And then we also have additional metadata on top of that. And you can add more metadata to make each of these binaries relevant to your organization more pertinent. And the thing is that one of the other things is that say you have the same file and you do it again, we never duplicate. So the idea here is that the SHA-256 values that we store the physical binaries and the metadata that we use is one of the essential bits, because number one, we do duplication. You have 1,000 projects all using the same common core library. We store it once and we reference it 1,000 times. You can go ahead and add more metadata on top of that to make it more relevant, like I said, to each one of those use cases. When you move binaries and stuff like that, you're actually moving, and where you delete, you're actually just going ahead and you're moving metadata. You're actually not moving the physical binaries. When you query or you do anything with Artifactory, you're querying at the metadata level. When you actually have better performance with our file system, you actually save space, right? Because you're not duplicating. I'll actually exemplify that just quickly, actually, as we're talking, just so you have an idea. If I show you my personal instance here, you can see that I actually have 363 gigabytes of physically stored binaries. If I went to its full size, it'd be 2.81 terabytes. Think about how much optimization that is. But the thing is that with this, we actually use that data to actually evaluate the binaries with our X-ray, which means in most other solutions, you need a physical binary to be evaluated, and then it breaks down, are there any CVEs or anything like that? Difference with us is that metadata representation is what we use. So our X-ray product is constantly scanning because it's metadata to metadata. It's metadata that represents the binaries that you've established that you want to go ahead and evaluate. And on the other side, we have this massive repository. Like I said, we are a CNA. And we have a combination of sources we use, NVD and NIST. We have RBS, risk-based security, largest proprietor of vulnerability data. We have our research team, which is massive. We're producing CVEs all the time. I think we have over 16,000 NPM vulnerabilities in our database. And we munge that together, and our X-ray product uses that data that we've produced as potential threats and issues, and we match that up against the actual binaries you wish to evaluate. And then we give you the ability to go in and create rules and actions to protect your organization best. Now, I talked about repository. What are repositories? Well, repositories are where you store the binaries inside of Artifactory. We have 3 different types. We have 5 in total. I'm only going to touch on 3 right now, which is local, remote, and virtual. Local repositories are where you store your things, right? Your builds, the files you upload, whatever they are, the things you generate, they get stored in a local repository. We also have remote. Those are those third-party transit dependencies. This is the reason why we're here. One of the things that we're talking about, all those headlines, this is where the third-party transit dependencies are. What this is, it's a lazy proxy. So by using, pointing your client, I'll use NPM as my example. So by pointing my client at Artifactory and I do my NPM request, it'll go through Artifactory out to the outside world. It comes back in, both the implicit or direct that I stated, and all the other transitive dependencies that come along with it. And they get stored there. So if you have 1,000 developers and developer 0 brings down a library and all its transitive friends, that means that all 999 other developers can utilize the same thing. Because when people ask me what we really bring to the table as an organization is consistency. So all your builds, if you use like 12-factor or multi-tier, all your builds are the same, promoted through your cycle, your SDLC, all those libraries are the same, consistency, and then security on top of that. And then we have like accountability and some other things too, by tying them into things like other tools like Datadog and Splunk and whatnot, where you can see how you're doing as a velocity as an organization and security coverage. Like I said, we have almost 8,000 customers. We have everything you can, and we have customers that are doing everything from, like I said, it's like I always look around, like from like Chick-fil-A to SpaceX, like we got it all, right? But then at the end of it, we have virtual repositories. Virtual repositories are an encapsulation. They contain local and remote repositories and allow you to have that single interface as a repository with more complicated structures underneath. So when we look at this, one of the nice things is that when you are working with a product and you're looking at these local repositories, I mentioned that you can store them the way you want. You should also consider your SDLC, your software development lifecycle, right? You're going to go ahead and design this, and you should design it because we have a promotion API that allows you to promote those binaries through the SDLC, dev, QA, staging, production, and accumulate as much information as possible through those stages. So this way you could have accountability for everything you do. But on top of that, we also, because everything is metadata based, we map all those dependencies to their usage. And we'll show some of that today because it's super essential. But on top of that, we're also going to discuss another unique feature today is the sheer vast overwhelming numbers of vulnerabilities. As I mentioned, there's a massive increase of attacks in software supply chain. How do you focus on what matters most? How do you delineate through these lists and save money? I mean, money is the biggest thing here, right? Not just the fact of time and effort it takes, which costs money, where your developers now spending more time on security and not on building things, but also too, are you delaying releases and feature sets that are revenue generating components in your company? These are all things that we can address with this. Now, if we look at, say, that same example I showed you before, where I was a developer and I bring an Artifactory into the mix, what's great is first of all, I'm going to create a remote repository. And this remote repository is going to allow me to proxy all those requests from NPM into Artifactory and then deliver to the customer. which in this case happens to be the developer, sorry, but I do a lot of work internally. Now, also too, I'm going to produce a build, right? I'm going to do an npm install and npm publish maybe. Well, that's where I have my local repositories, dev, QA, staging, production, whatever. And then I'm going to encapsulate them into a virtual repository. So I'm only interacting with a single source here for me as a developer. So my third-party transit dependencies I have, and also the builds I produce, and I can go ahead and accountability in the SDLC. So when I go ahead, it's very simple for me to go register, in this case, with my my Artifactory instance by just modifying my package.json. I can use my standard npm install, or I can even use our JFrog CLI if I wanted to. And now when I do all my requests and everything, all my interactions as a developer will be through Artifactory layered in with our X-Ray product. So when we look at this and you look at what we offer as a solution, and we have an end-to-end DevSecOps or platform engineering platform, is that we're going to go from left to right on this, just so you understand everything I'm going to show you. So first of all, Artifactory, right? Cornerstone of our technology. That's the third universal binary repository manager. It's the place for those third-party transit dependencies, and also to the place where you store your builds. Correlated next to that is X-Ray, which is our security vulnerability, license compliance, operational risk. And one of the things we'll talk about today is contextual analysis. We can also do things such as, are these issues applicable to the usage in which you're doing things, number one. Number two, we also can help you find, service exposures, secret exposures, infrastructure as code analysis for things like Terraform, right? These are all layered in. To the right of that, we have distribution and connect. Distribution is our distribution platform. It actually is the hub, and then the spokes on this happen to be these lightweight immutable versions of our Artifactory product called edges. It allows you to get your software to where they need to be. They're self-hosted or managed through us, because all of our stuff, if you're not aware of all the other things we offer, I'm not going to go into the level details, but you can be in your cloud, our cloud, hybrid, whatever. It doesn't matter, but you can distribute to wherever you want, whether it's your customers or web services, say in a web, one of the cloud offerings somewhere. We have JFrog Connect, which is our IoT platform. It's a device manager, device diagnostics, device updater. And then below that, we have pipelines, which is our CI, CD, and CI orchestration tool. Each one of these has big, huge webinars and tons of information on our site. I'm not going to go into too huge a detail. If you want more information, just contact us. We'd be more than happy to talk. But let's look at a real-world scenario around this, right? The first thing everybody always talks about is shift left, right? We talked about the developer. We talked about where it matters most. And when that's curation, right? So you have your developers actually going ahead and building out the things that they built, and they're curating those binaries, either automated behind the scenes through Artifactory, which I'll show you in a few minutes, or we also provide information to the developer through things like ID plugins, right? IntelliJ, Eclipse, Visual Studio. So they actually can attack it where it matters most. Just to let you know, the ROI on your developers addressing these security issues is 100 times more cheap than it is once it's in production. It's 100 times more expensive for you to find a security issue that's in production and fix it than it is for the developer to address it where it matters most, or even better, preemptively stop it before it begins. And also too, with continuous security, have it so that they don't, if a new security issue comes out, stop it before it even starts, right? So in other words, they've already been using it, a new 0 day, like let's talk about Log4j, right? Yesterday it was fine, today it's terrible. How do you stop your developers from utilizing things that have been deemed inappropriate on top of that? But it's also part of the creation process. Well, the thing is with CI/CD and DevOps, the idea is automation, right? GitOps, you hear it all the time. BinOps, if you're using the binary abilities, whatever. But the same thing is consistent, right? You're creating software, whatever CI tool you're using or things like that. And this allows you to, when a developer is developing and using those libraries that are already stored and embedded with X-Ray and Artifactory, when you start introducing your CI tooling, this allows you to use those same level of binaries and also add in security as part of that protection. Once again, it's an ongoing process, and behind the scenes, the thing is it's metadata, it's constantly evaluating. You don't have to manually instantiate something to do it. But of course, when you create software, you need somebody to consume it, right? And the entire process has security all the way down to the end. Actually, towards the end of this year, sometime this year, I'm not going to say when, we're also introducing some other things too that will make things even more optimal, such as code analysis and also to runtime analysis. And one of the things you always hear about, by the way, we'll also discuss a little bit here is that a lot of industry now, and it started back in 2020 around May, when the Biden administration talked about software supply chain security for the government, is that software bill of materials. What is it? You hear it all the time. And this has become also very pertinent, and actually also in other industries, avionics, medical, utilities, whatever, now has become more and more a request. And we have the ability, besides just having continuous security throughout the entire process, but also the ability for you to produce a software bill of materials. So when we talk about what we offer as X-ray, besides being completely continuous, always evaluating, is it can scan any of the package types, including things like Docker containers, right? So scan any software at any level. Getting full visibility, right? So software bill of materials, lots of rich data that I'll show you that our teams have produced, right? Being able to constantly monitor and evaluate and alert based on new 0 days and things like that. Being able to also to remediate faster, providing information like contextual analysis, also too at the developer level, being able to say, hey, that library you're using is potentially threatening. Here's a version that actually fixes it, and being able to fix it right away. On top of that, being able to control it yourself, right? Being able to actually build the policies that matter most. There are other security aspects, RBAC and all those kind of things, but the idea here is around the binary portion of this, but basically being able to go ahead and provide some level of curation for your developers to make sure that that amount of things that they use to do their job are the safest and most compliant as possible. Being able to integrate it no matter where you are. I'm going to show you the UI today, but I'm also going to show you our JFrog CLI. I'm also going to show you the fact that we have integrations into all the major CI/CD platforms out there, right? And if we don't have it, you can actually write your own custom integrations because we have all these tool sets available. And then lastly, we're everywhere, right? So you can either have it in your own DC, you can have it in your own cloud, you can have it in a public private cloud, you can have it in, have us manage it for you. It's available everywhere. And the thing is that the next level of this, we've upped the ante on what we can do. So we're now doing infrastructure as code analysis and secret detection, malicious code detection, right? Application and service level exposures. These are real world components that need to be evaluated by every company because each one of these leads to a potential threat and loss of revenue. And the thing is, as I said, there's a reason why we call this continuous, right? So it's constant levels of security and constantly being able to have it so that you know what's going on in terms of your security posture as an organization, where it can really threaten the things you do. And you heard me mention software bill of materials. I'm going to give you a 2-minute explanation so this way you understand why everybody is talking about it. And it's very simple, is that, we've actually, the thing is actually, just so you're aware, it's nothing new, right? But in 2020, in May 2020, right, the government, executive order on improving the nation's cybersecurity. Well, I had to go read it. It was terrible. It wasn't exactly an exciting page turner, but section 4, enhancing software supply chain security. This was a major aspect of it. And one of the ways, besides, tool sets and whatnot, which they didn't implicitly really state here, is provide us with the information on what's in your software. Now, just so you know, it's not IP, right? There's no IP information as part of this. There's none of that kind of thing. Basically what it is, it's the equivalent of a list of ingredients, right? It's funny because actually the FDA was the one that actually did this initially back in 2018 around medical devices, right? Software runs on medical devices. Do you really want to know, like the components? Yeah, because these things can kill people, right? And if there's a vulnerability in there that could potentially cause the software to catastrophically fail on a pacemaker or a kidney dialysis machine or a heart, or basically a ventilator, you're going to want to know so you can retrace your steps. So let's talk about things, right? Let me show you an example of a couple of things, right? So let's go dive in. Number one, let's go ahead and let's go look at some of the information that we provide to you as an organization. Now, for my example that I'm going to show you here, I'm going to actually focus on a couple of things. So first of all, let's go in and take a look, first of all, at the repositories. right? We mentioned repositories. I talked about the storage aspects. And under the repositories, you can see I've got my local, my remote, and my virtual. Now, we support, like I said, over 32 package types natively out of the box here, and I do mean natively, and we'll talk about them. Each one of these has its own aspect in which you can utilize it. And no matter what you choose, I mean, maybe in this case, I'm choosing Docker. Docker always seems to be a good one to choose. It's highly complex. I like Docker as an example. It's got an OS, it's got a runtime, it's got the application you have living in it, right? There's tons of stuff in here. But when you define your repositories, I have a naming convention document that we have online, and I can say, you know what, I'm going to call it test because that's my product. In this case, if I can spell today, and then on top of that, I can name my repository like dev, QA, staging, and whatever. But I can do replication. I talked about replication before a little bit. You can replicate. So this level of security and consistency you have isn't just isolated to a single location. It can be global organizations. We have some of the largest organizations in the world using us. But at the bottom of this, I have enabled indexing in X-ray. Now, by enabling indexing in X-ray, it lets our X-ray product know that this binary, no matter what it is, and all its friends, all those transitive dependencies, anything that's stored in this repository is now available to our X-ray product for evaluation, right? I now have the ability to go in there and actually let X-ray know that any rules and stuff that you have are here and you should define them. And now you can utilize this for evaluation. And this goes down to those third-party transitive dependencies too, right? Because if you look here, what's nice is that when you look at, say, a remote repository, and let's just stay with Docker for a minute. So I can call this thing, and I already have a version of it done. So I'm just going to say Docker remote, which is going to complain that it already exists. But it's going to point to this third-party transitive source and act as a proxy to get to it. So whatever those third-party transitive sources are by type, it will be handled natively on its proxy request. You can use paid accounts and free accounts and TLS and access tokens and whatnot. But at the bottom, once again, we actually have enable indexing in X-ray. We're letting our X-ray product know that any binaries that are in this repository need to be evaluated. And of course, the last part of this is virtual repositories. Like I want you to be able to see this, right? Because this is all part of the continuous security process. And since we were talking about Docker, and I'll just show you the example, actually in this case that I'm utilizing, for the example I'm going to show you in a minute, this is my repository. Now, this is a terrible name. It shouldn't be named this way. But below this, you can see I've got prod and staging and QA and dev and my remote. And this is my resolution order. If I do a Docker pull, it's going to pull from prod, it'll check prod first, staging, QA, dev, and remote. Now you might ask yourself, we'll be like, well, that's kind of weird. We got to go searching through each one of these. Remember, it's metadata. It's based on queries. It's not physical binaries that you're actually trolling through like a file tree or something, right? This is much more succinct. It's very extremely fast and rapid in its response. And if I want to do a Docker push, I can actually deploy it to say a dev repo, and then we have a promotion API that allows you to promote those binaries through the cycle. Like I said, if you follow 12-factor or multi-tier, any of these schools of thought, when it comes to the development, one of the key factors here is the atomic unit. Whatever you produce in dev should be the same thing when it gets to production. Any variance or deviance of that is bad. This allows you to have that consistent nature. Now that you've defined your repositories, right? I'll show you how to implement them in a minute. Let's go ahead and look at X-ray and the things that you can do. This is very essential. So now what can I do is it, right? So I've got a list, I've got a whole bunch of binaries that I want to evaluate, right? I enable indexing in X-ray, or I upload. We even have on-demand scanning where you can use our CLI tool and evaluate something. But on the other side of it, we have that massive metadata of all the potential threats, vulnerability aspects that we've done in terms of CVEs and whatnot, right? And how do we get to do something? What are the actions? What can I do about that, right? Having the data and having the binaries are fine. If I don't have actions, what do I do? So let's go ahead and look. So under X-ray, we have watches and policies. Policies are the rules and the actions you take, and policies and watches is how you actually implement them. So let's go look at a policy first, okay? So you give the policy a name, right? So you might, it might be a security policy. So I'll say test, sec, whatever. If I can, oh man, I can't type today, huh? Let's get those fingers on the keyboard, right? So it might be a security policy because we have 3 different flavors. Yeah, we don't have a lot. We're Neapolitan, or if you're in the EU, we could say it's a Coronado, right? But here you go. So you have security, licensing, and operational risk. Let's talk about security first, right? So security, I can create a series of rules, and based on the severity of the issue, I can have specific actions. So let's take a look. So first of all, I would give my policy a name. And then I would go in and say, what's the severity level I want to evaluate it against, right? So it's CVE, so it's actually low to critical. By the way, a little pro tip, always have all severities, in my opinion. Like when Log4j happened, remember, CVEs just don't happen, right? They're reported, they're investigated, they're peer reviewed, then they're created, peer reviewed again, and then released, right, as a CVE. Log4j had a bunch of info and warnings coming out before it was actually announced that this thing was horrible. Or you can use CVS score, right? V2 and V3. So you'd actually select your, what is your range of CVS score, and then do something. Now, the action, in my opinion, are the fun parts, okay? So first of all, let's get a generate violation. And I'm going to show you some violations in a minute. You could also do things like trigger a webhook, right? It's just a simple JSON post. You might have your own system that you want to queue off that does crazy things on the back end from your CSO team or whatever, and this will allow you to do that and publish whatever you have there. You can also, one of the parameters we have with policies and watches is under watches, you have the ability to add an email address. It could be either individual or a list. And this says, hey, you know what? Notify the people on that list. We also have deployer. Somebody deploys something into Artifactory. We evaluate it. Let's notify them that they did something naughty and that they're bad people. No, I'm just kidding. Anyway, but you have to be able to do that. We also have a separate email address. Now, the separate email address is maybe for critical issues. You might have red team that comes out of nowhere and saves the day, right? They might be separate from your standard. Or you can create a Jira ticket. This is one of my favorites. I love this integration. By the way, we also have integrations to things like ServiceNow and PagerDuty, right? So anything where you can get real-time updates. In this case, we just have the Jira thing and just kind of show you, here's a Jira ticket, right? This is actually an extra security violation. Here's all the information, so it's actionable. And I can go ahead and even link directly back to the component that actually caused this, right? This is direct information in that respect. The next is the fun one, right? Remember I talked about maybe something you were using yesterday was fine, like Log4j, and today it's the worst thing on the planet. It's going to cause you lots of heartache and tears and all that stuff. So we have block download. What this is say there's a new 0-day that's happening, block download, and it gets evaluated, a new critical issue comes out. The binary you were trying to pull yesterday is now marked as critical. You cannot consume it today based on this rule. So you can go in and investigate it and figure out what the hell happened, fix it, do what you need to do. And then you could also say, you know what, this isn't affecting us. I can allow it. So you can actually override it. But I mentioned shift left before, right? This is part of the continuous security aspect. Let's talk about behind the scenes. So first of all, you want your developers, like I said, to do what they do with as little intrusion as possible. So first of all, block unscanned artifacts. Block unscanned artifacts means that when they proxy the request to a third-party transit source, it goes out, it comes in, Artifactory holds on to it, does not deliver it to the developer or tool, whoever requested it. And it evaluates it, it's metadata, it's fast, right? And the thing is that it'll evaluate it. If it meets your criteria, and not just the implicit, but all its transitive friends, it will actually go ahead and then release it to the developer. If not, you will get an error, you'll get a message saying that this is a policy violation and you need to fix it. We just added in a safeguard behind the scenes that developers don't realize, and they can go ahead and they can pull all the things they want, but you're still watching. But what about at the developer itself, when when the individual is coding what they're doing, right? Well, I mentioned IDE plugins. So one of the things that we have here is like, here's an example here of in this case, just an NPM project that I'm doing. You can see the hierarchy of the binaries I'm using. And then on top of that, you can see if I select any of these, it shows me my CVEs. And if I click in here, it can actually show me all the components, including reference materials and whatnot, and also fixed versions. If I go to the package.json even and say I hover over any of the items in the list, it'll actually show me, are there any potential threats and issues that I should be aware of? On top of that, we also offer the developer at Shift Left the ability to use our JFrog CLI. Here's a project that I'm working on, and I actually used the JFrog CLI to do a JFrog audit, a JF audit, and that went through and it said, oh, here's all the strands of dependencies you're using. Here's any potential threats and issues you have. Or what if I download a jar, right? I find a jar that might do something. I created this jar, just so you know, and it's terrible. It's horrible. You can see here where I've actually gone in and I can even scan this jar on demand and get the results back at my desktop without even having to go. Our JFrog CLI, one of the nice features of it is that if I show you here, is that you can work with every piece of our product, number one, and very specifically, you can also go ahead and do other issues such as, complete access to what we do as a solution here. Say you're using Docker even, right? You install the Docker client, it comes along with the Docker desktop. Well, you can even integrate our actual component here, which is our extension. Well, you can go ahead and actually evaluate the binaries that are inside of any image, even if that image is not in an Artifactory, which I will show you, by the way, why we have absolutely the best Docker registry out there. And I'm not just biased. I'm actually, you'll see why in a few minutes. But let's go back over here. Now, what we have here below is in our distribution side, there's a thing called a release bundle. I'm not going to go too deep into it. Just picture it as a way to package up things like, say, Helm charts, Docker images, and Terraform templates and publish them out as one immutable release. That's what it does. But you can also make sure that it's safe, that it's secure, that it's been evaluated too. Then we have fail build, right? The obligatory exit event. This one here will just send an exit event, whether it's a CI tool, CLI, or whatever, it sends that event itself. One of the biggest complaints we get is that say you have 100 developers and developer 0 brings down a thing and kills the build for all 99 other developers and everybody gets really mad, because you don't want to have a knee-jerk reaction fix to find one of these vulnerabilities, right, or remediate it. So why don't you allow a grace period? You know what? Notify them, but give them 2 days to fix it. And all the other developers will get that same notification. So this makes time and effort for a developer to go ahead and say, oh, you know what? Actually, we should probably take a look at this a little more in depth because you get the proper response. Another thing is legal teams and whatnot. And also, by the way, just so you know, a clear indicator of potentially nefarious or malicious third-party libraries is licensing. Right? So if I go under the new rules and I give the rule a name for licensing, you can see the criteria, which is be the if statement and the actions. And just let you know with licensing, I'm not going to go through all the options here because it's actually the actions are exactly the same. But what you have is you have the allowed license list, all 437 true open source licenses. You can say this is my allowed licenses, my banned licenses. One of my favorite things is disallow unknown licenses. These are usually clear indicators that if it's an unknown license, not part of that list, there's a good chance it's a threat. Or why does this have multiple licenses? This is another clear indicator. Most of the time, this has to do with things like binary spoofing or typo squatting. You accidentally type in the wrong name of a library. There's somebody out there, I'll tell you right now, that created the wrong name of that library that actually probably contains malicious content and maybe has a different license. The other thing too is that operational risk. Now, this is something that is a concept that we're bringing forth for our customer base to understand, right? You're building the latest, hottest, greatest software. In this rule set, the criteria in this case is defined that says something minimal risk, high, medium, and low, and a bunch of conditionals. What does this really mean? Well, what it means is that we're actually helping you evaluate the actual health of the open source libraries that you're utilizing, right? So is this end of life? What's the version age? Is there a new version available? And what's the health of the open source project? Remember, I told you, a lot of these projects are old, outdated, or completely abandoned. This is a way to level protect yourself to figure out what works best for the company. So that you can see here, you can even go either by our standards, right? So we actually have a comparison matrix on like how we determine high, medium, and low below right here. Or you can make it more custom to the way you operate. So once you've actually gone in and created a series of policies and rules, the other part of this is how do you implement them? And the way you implement them is through here. Like we actually have the ability for you to go in, you create a watch. Right? So you give it a name, you give it a description. Here's your email list. Here's where you can connect your Jira. You can choose to associate it to a project or repositories or builds or bundles. You apply your stuff. and then the magic happens. So in the time that we have left, I want to show you why this matters most. And to show you that, I want to exemplify that, like I said, with a single example. And it's my favorite example to show. It's a very simple Docker build, okay? It's actually, in this case, it's actually being built in my Jenkins server, so I can go ahead and just show you. It's a very standard build. Actually, it's getting all of its dependencies and everything and X-ray testing, and I'm promoting it through its cycle, all these things. I automated everything. I like automating. And let's go take a look, right? So first of all, I mentioned the SDLC, right? So I can promote through the binary cycle. If you look here, it's been released. This is an arbitrary value I can set. You can also see this is critical. This thing is bad. Oh, it's terrible. But let's go take a look at the build. So first of all, here's your standard Docker registry. Really doesn't tell you much, right? So immediately, if there's an issue with your service, you're already starting off poorly, right? Because if I ask you as an engineer and I say, hey, what version of the application are you running in this? Most of the time, everybody's like, well, it's going to take me time. I've got to go in. I've got to, remember we talked about the 26 days that people like, well, doesn't tell you anything, right? I got to investigate it. This can be time, money, and effort. Once again, cost. Well, if you do our best practices, I can show you. Here's my Node front end, and here's my Java backend. I can see them right here. I know what versions they are. What if this version is terrible? Performance is abysmal. Well, what I can also do is go in here and even compare the application layer. I just save time. Well, it looks like my Node front end stayed the same, my Java backend changed. We can show you if there's any environmental and system information. Once again, it's consistent. I can map all this information. But the X-ray data is the biggest thing. And just to kind of exemplify, we have violations and security and whatnot, but let's go and find a particular issue, right? My favorite issue I always like to show, this is a Spring Boot app. I'm using XML data, so I'm using Jackson. My front end uses this XML data. Well, I can select any of these CVEs, first of all, and tell you, look, it's critical. Our security team says it's medium though, because the CVE is terrible. Somebody did a cut and paste of the summary into the description and gave me no context. Our data is rich. Remember I mentioned we're a CNA. So if you look here, we actually have a very small thing that says basically it's unknown, but our research data tells you every little detail in what we found out and how you can actually fix it yourself by just changing part of it. And we even offer you remediation, and we also offer you too the reasons behind it. But the best part is that because it's continuous, we do that also. The thing was, remember I mentioned the fact that we also, besides continuous security, that when we map everything via checksum, you can see here that, we actually found, because we break it down to find that checksum, jar files, tar files, war files, zip files, whatever, you can see how this jar in a jar of a layer of an image of the build. We found this buried deep inside. Here's all the license files that are here. Here's all the operational risk components, right? What versions are here? What version is being used? Is it end of life? What's the latest version? Here's the descendants. This is one of my favorite views. Once again, here's those layers of that black box we call Docker, right? Doesn't really tell us much of anything. Well, we actually break everything down so much that I can even show you here that, here's a version of Angular. I can view the component, or I can even override its CVE. If I need to produce reports, I've got reports here: violation, licensing, security, operational risk. I can even, here's my SBOM, SPDX, and cycle and DX formats with one button click. I can show you any JIRA ticket issues I might have here. I can show you the diff between full things like images. Think about it. I'm diffing two Docker images to tell you what's different between them. Wrap your head around that for a second. And here's the history, right? I can have every phase of my SDLC with as much pertinent data here as I need to make sure. I recommend companies actually putting as much data here, including QA testing data. Did it pass the test? I can go here and have a single source of truth. But here's the part where it really ties the whole thing together. Let's go look at this. Let's go look at this NPM map at the application layer, right? I'm going to show you. Here's the tar GZ and all its contents. Right? If you look here, here's all the pieces behind it. I can tell you when it was built and when it was downloaded. This is all accountability. These are ways for you to do your job more optimally. I can even show you its own dependencies. I can show you its permission. I can even show you its own X-ray data around this component, including things like security and licensing. Here's all the metadata that I've collected over time, and I can add more metadata to make things more relevant. I can even follow a binary telling me, notify me if somebody, I don't want somebody to use it. And then lastly, this is the best part. We went from the Docker image to the application layer. And if you look here, I can show you, here's the build that produced it. But here is every single container that's ever used it. Think about this. I'm saving you time, money, and effort, right? Because you can go in quickly, find out how long you've been exposed. I mean, this even goes down to, like, say I do a search for, say, something like Lodash, right? Or a binary. I read an article. I can click on here. And when I go in, this will actually allow me to go in, and see every version of this library that's been stored, its issues, right? If there's any scanning, say this is the version I read about, I can say, my CSO asked me, hey, who's been affected by this? How long have we used it? Well, most places will be like, I don't know. Well, here I can show you every single build this is touched. But we're also mitigating one other thing that I want to show you. And I think this is super relevant and super important. Let me log into my test instance over here. Now, the sheer volume of CVEs that companies are facing is ridiculous. So kind of to show you here, I've got a list of vulnerabilities, okay? I have 135 vulnerabilities that I need to go through and see, are we really being affected by it? That's time, that's money and effort, detraction from innovation. Well, take a look at this. I can go through this quickly and parse and let you know, hey, you know what? This CVE is applicable. We do contextual analysis to let you know, are you being affected by this critical CVE? Yeah, we are. Well, here you go. We also just cut down the amount of time it takes for you to do it because we show you where. Where are you being affected by this? We now pinpoint, laser focus the things that you're affecting, cutting down the amount of time for investigation and remediation. And that includes also letting you know, yeah, you know what? Don't worry about this one. This one is a high, but you know what? You haven't implemented a specific function. Also, we're protecting you against things like secrets. This is one of my favorite ones I showed. I downloaded a standard actual Python hosting app, right? A Docker image. Look at this. I found in the root history private API keys. And also things like service level exposures. And also, too, infrastructure as code has become more prevalent, but it's also error prone. And in this case, I'll just show you, I've even found things where I put in, this is a test I did, I even put in things where I was like, here's all the, here's all the ACLs I want for authentication. None of them's adhered because I accidentally left on the authorization none, right? These are things that we see every day with the customers that we work with, and we provide them with tool sets to save them money, time, and effort to make sure that they're safe and secure and being continuously evaluating so that there's no, you don't have to cut time out of your day somewhere to go do these evaluations. It's always present, it's always there, it's always protecting you. Thank you for your time. I hope you guys really appreciated it. I'm taking a look in the chat and see if there's somebody who had any questions. If not, I really, really appreciate your time in joining us today. And I hope everybody's safe and well and have a fantastic day. Cheers, everyone.
Thank you so much again, Bill, and feel free to reach out to us to schedule a demo, to have a one-to-one, and our email address is webinars@jfrog.com. Thank you again, Bill, and thanks everyone. Bye.
Have a wonderful day. Be safe, everybody.
Bye.
Cheers.